In this exercise, we have several questions to practice the built-in data structures in Python. In the first question, we're being asked to create a list called year list, starting from the year of your birth and each year hereafter until the year of your 5th birthday. So for instance, if you were born in 1980, the list should be 1980, 1981, and so on. Okay, so assuming that that's the case, I can simply list the values 1980 to 1995. That's basically constructing the list. Now, many often we want to create those lists of increasing integers without being able to, without needing to type all of them. Let's say, for the sake of this example, ending at your 25th birthday. Okay, that will be a more typing for us than just typing these values. So to do this, there is a special function in Python called function range. Range basically gives us a range of values starting from a beginning, ending at an end, and the end is exclusive, very much like a list. So the range from 1980 to 1986 is going to give us 1980, 1981, 1982, 1983, 1984, and 1995. We will see this function, we've actually seen this function with loops, but we will see it used more many often. That's a range object here. It doesn't give us a list, it gives us a range object, and then we need to convert it to a list if you want to get a list. So the other way to do it is to say, okay, year list is a range from this value to this value. Oops, I don't know what I did here. Year list is a range in between these two values. So the range function itself is very much like slicing. That's the same conventions as slicing. Beginning inclusive, end exclusive. Well, it actually provides us a way to have an optional step if we wish. So it's the same conventions, which makes it very useful because if you memorize the convention of slicing, those are the same conventions. This is going each other year, step of 2. Next, it's asking us in which year in year list was the 3rd birthday. So we should remember that the first birthday, it's not a birthday, it's when someone is born, and this is age of 0, right? We don't celebrate our 0th birthday. Our 3rd birthday in this case will be in 1983, which is the item at location 3. So we can simply index years 3 at position 3. So the 3rd element in the list should be years list at 3. Well, it's not the 3rd element, it's the 4th element, but that's the 3rd birthday. Okay, so in which year in your list were you the oldest? That's obviously the last element in the list, and the easy way to get the last element in the list is to go negative at -1. That's 1985. Okay. Now let's make another list called things and list 3 things: mozzarella, Cinderella, and salmonella. Okay, so I'm going to assign a list of these values here. Well, I'm going to copy paste them because I don't want to type these values here, so just copy paste, and here it is, things. Okay, now capitalize the element in things that refers to a person and print the list. Did it change the element in the list? So we need to access the element in the list that refers to a person, which is Cinderella. So that's the element at location 1, things 1, Cinderella, and then I need to capitalize it. Now notice that things 1, this whole thing is a string. So I can call the function capitalize here and get that thing capitalized. Now, if I just do this, the list itself did not change. However, if I assign this back to the list will change because I capitalize things and I put it back into the list. If that's what I do, then things will change and I will see that Cinderella is now has with a capital C. Okay. So it depends on what I do. If I just capitalize it, nothing will happen because I just created a new string and put it nowhere. If I capitalize it and put it back to the list, I put that new version of the string and overwrote the old one. Okay, so let's make the cheesy element of things all in uppercase and then print the list. I'm going to do the same. The cheesy element is things at 0. So I'm going to do things 0, and because this is a string, I can do upper here and I can print things and it will show with mozzarella capitalized, all caps. Okay, delete the disease element in the list. And the disease element is the last one, salmonella here. There are a couple of ways to delete an element from the list. One way to delete the element is to basically slice the list. If I slice my list to be 0 to 0, 1, 2, notice that 2 exclusive, that's going to delete the element here. Okay, so that's one to delete it, and then I need to assign it back to things. So basically creating a new list and assign it back to things. If I do this, I effectively deleted the element. I'm not going to run this cell for now because I want to show you 2 more ways for doing the same thing. Okay, so let's call it things 1 actually. Let's do this. Let's call it things 1 because I want to keep things intact for now. And you can see that things 1 is effectively the first 2 element in things. Okay. Let's see another way to do it. The other way to do it is to basically assign something in things -1. Now things -1, you can see here it's an item here, right? So I can assign here -1 to be none, but that will create a list that has none inside it. It will not delete the element. If I do this, you can see that I've got none in the list. So I erase the value but put none instead of it. Let's reinitialize this here. So what I need to do here, I need to take a look at the slice from -1 to the end. The slice from -1 to the end is going to be this list, which contains 1 element, and I'm going to assign an empty list here to be equal to the slice. Now if I take a look at things here, I'm going to see that I effectively replace the last slice, a slice of element, with an empty list, which means I have deleted this element. Okay, so let's recreate things one more time here. The last way to do it, and is probably the easiest way, is to use a function called pop. You can think about the function pop very similar to append. Append adds an element to the end of the list. Pop removes an element from the end of the list. So if I do things.pop and things again, I'm going to see the last element deleted. Okay, now let's create a list called surprise that has the element, these things, Gruchu, Chico, and Harpo. So I'm going just to list them, copy paste, and obviously all commas here. Okay. Lowercase the last element of the surprise list and reverse it and capitalize it. Okay, so there are a couple of things here. We need to lowercase the last element. What's the last element? The last element is surprise -1. Okay. Now lowercasing it, that's a string, so I'm going to lowercase it using lower, and I'm going to get Harpo all in lowercase. Okay, reverse it. How do we reverse it? Now the trick in here is to realize that, well, a string is also a sequence. So I can also slice a string very much like slicing a list. And this is something we have seen when we did the string operations. So what I'm going to do, I'm going to slice it. And remember the slice used to reverse something? It's beginning, end, -1. That's basically going backward. And that's going to give me opera here. That's the reverse of Harpo. And the last one is to capitalize it. and that's going to give me opera. All right, so all of them are chaining the operations because there are no side effects. They're giving me a new string at each steps. Okay, and I think we need to put it back in the list. It doesn't say you need to put it back in the list. So that's it. Okay, if you want to put it back in the list, I'm going to put it back in the list. Surprise -1. Surprise! We've got a new list. Okay, moving on to dictionaries. So let's make an English to French dictionary called E to F. And the associations are the following. Dog is chien, cat is chat, and walrus is morse. So those are my associations, and I'm going to create the English to French dictionary here. Of course, curly brackets, because the dictionary, of course, each one of these is a string, and no, there is no is, it's an association. Oops. So it's an association. Of course, there is no and. And here we go, E to F. That's English to French dictionary. Now, using E to F, print the French word walrus. That's basically indexing the dictionary, E to F. But because it's a dictionary, I provide the key and I get the value back. So walrus should be morse here. Next, we should create a French to English dictionary called F to E from E to F. So basically we need to do the opposite, the reverse. There are a couple of ways of doing this. We're going to use loops today, and next time when we learn about comprehensions, we can use a dictionary comprehension to do the same. But basically we need to loop over English to French and put the opposite value key associations in French to English. So the way to do it is to create the French to English dictionary here, and then to go for each key in E to F. And it's important to note, when we loop over a dictionary, we loop over the keys. So then the value here is E to F of key. And what I'm going to do, I'm going to put the opposite key value association. So I'm going to create an entry in French to English in which the key is the value and the value is the key. F to E here is going to be the opposite dictionary. The other way to do it is using the items method. Remember the items method that give us items here in a tuple way? So what we can do here, we can do well, F to E is equal to a new dictionary, and then for each key and value in items, because each one is a tuple, so I'm unpacking the tuple. F to E V is equal to K, and F to E is going to be that dictionary. Now we will see this next time. I'm just going to give it to you as a sneak peek. This is a loop that creates a dictionary. A loop that creates a data structure in Python can be compressed in what we call a comprehension. So we can write what we call a dictionary comprehension. It's basically something very similar like this, but it has a special syntax. You can think about it as a template to construct the dictionary. To construct the dictionary, I'm associating V to K for key and V in E to F dot items. That's basically giving us that French to English dictionary in a comprehension in one line, rather than putting it in separate lines using a loop. Okay, so that's the syntax we'll learn about next lecture. It's called a dictionary comprehension, but basically you can think about it as a template for creating the dictionary from a loop. Okay, now next let's use F to E, the dictionary, to look up a certain word. For instance, what's dog in what's the word equivalent to chien in English, so F2E, chien is going to be dog. Now notice that again, when we index a dictionary, we should be careful that the key has to exist. If the key doesn't exist, we will get an error here. So if I do here F2E with something that doesn't exist, for instance, F2E of bonjour, I'm gonna get an error here. Okay, so the key has to exist, otherwise we get a key error. Okay, make and print set of English words from the keys in English to F. Basically, we need to get the keys, so that's the function keys, e to f dot keys, and it's asking us to make it a set, so I'm going to make it a set. That's it. I can assign it if I wish, and just print the set here. Now, let's make a multi-level dictionary called life. A multi-level dictionary, it means some of the values themselves are dictionaries. Okay, so we have the following. We have the topmost keys being animals, plants, and other. Make the animals key refer to another dictionary with the keys cats and octopi and emos. And make the cat key refers to a list of string with the values Henry, Grumpy, and Lucy. Make all of the other key refer to an empty dictionary. So first, we have a dictionary. And I'm going to break it on multiple lines because it's a multi-level dictionary for ease of presentation. We have three topmost key: animals and plants and other here. Okay. Now make animals key refer to another dictionary. That's another dictionary here in which we've got the keys being cats, octopi, and emos here. Make the cat key refers to a list of string. Next, this is the association: Henry, Grumpy, and Lucy. Okay, don't forget the comma. Now make all other keys refer to empty dictionaries. So this one will be an empty dictionary. This one will be an empty dictionary. Of course, don't forget the comma here. Here is a comma. This one will be empty dictionary, comma. This one will be empty dictionary. And I think we should be good here. Okay, so what did we do? We created a dictionary. That's what we've done. But some of the values in the dictionary are data structures, such as other dictionaries. And the other dictionaries, some of their values are other data structures, such as a list or such as other dictionaries. Now, this nested data structure is very common, and on the internet is very commonly used when we interchange data with data providers. Indeed, if you've heard of the word JSON for JavaScript object notation, it's relying on a similar idea that you can represent a complex object as a hierarchy, and a hierarchy of associations between keys and values. This is something we will get back to when we talk about reading data from APIs from the internet, and you will see that we'll be using dictionary mostly when we read this data into Python. Okay, so let's print the top level keys of life. It's basically life.keys. Of course, if I want to convert it to a list, I can convert it to a list. If I want to print, I can pass it to print. But those are the top level keys. Print the keys for live animals. So live animals here is going to give us another dictionary. So I can do the same. I can do .keys, and this will give us octopi, cats, octopi, and emos. Or what I can do, I can just do list of them. Oops. List of live animals, and this will give me these keys here. Now I can print using the print function if I wish. The key important point in here is that we are extracting the keys in the second level dictionary here, animals. Now we want to print the values of the cats. So live animals here is giving us a dictionary, and this dictionary has an association between cats and the list of the cats here. So we want to further index this dictionary. Notice that this whole thing is a dictionary, so there's nothing limiting us to further indexing using brackets, because this whole thing is a dictionary. If it makes your life easier to put a parenthesis, you can put a parenthesis just to emphasize this whole thing is a dictionary, but you don't need the parenthesis here. Live animals, cats, is going to look up the values associated with cats in the dictionary, which is live animals, because it's a second level dictionary in the dictionary live. So obviously this is the list. If I want to print each one of them on a line, I can do a for loop. So, but again, the point in this exercise is just being able to go and pull the value from the dictionary.